Hi everyone, welcome back to Lab 8 Part 2. As we just left off, we were creating an attribute query for selecting land class with the standard forest land and the stand conditions of solid timber. So we had used this like operator instead of the equal sign operator to create a partial string search, which uses the expressions of saw timber to include anything that has any field that has the name saw timber in it. And so if we had applied it, and it comes up with 93 selected attributes. So you have now selected all the stands in the forest satisfying our conditions that have saw timber in the name. So you can dock this attribute table anywhere around, so you can see these little purple buttons. I docked it down here. You can also manipulate the dock a little better so it isn't the whole area, but it is just, it is just, I guess maybe if I do it this way. Okay. There we go. So I just did it so the table of contents is still there, but the attribute table is now within the map document. So we will continue. So from here, we're going to select stands crossed by roads or directly adjacent to the road, and we're going to click on the selection menu and click the select by location. So we're going to click the selection menu, select by location, and from the drop-down menus, we're going to select the method, select from the currently selected features in, so it's the last one. The following layer, we're going to check the box of stands, which indicates the source layer for the selection, and then, so we're going to select from the currently selected features in, which includes the stands layer, and now we're going to indicate the source layer for the selection as the, roads in forest. So for the spatial selection method, we're going to select the target layer features intersect source layer feature. So intersect source layer feature. So it's the first one, it's already selected as our target layer feature. So make sure the distance checkbox is not checked. Click apply. And you have selected saw timber stands where harvesting is allowed, which are also crossed by roads. So that actually diminishes our amount of selected attributes to be about 73. And so now we're going to open the attribute table again and perform the query again to select saw timber stands where the harvesting is allowed as done previously using the query. So I'm going to go back, close this, select by attribute, and I believe it is all the same. Click apply, and so that brings us back to the original 93 selected attributes of just where harvesting is allowed, which was done previously. So now we're going to select stands which are closer than 50 feet to roads. So we're going to click on the selection menu again. We're going to select by location. We're going to make sure that select from the currently selected features in selection method is selected. We're going to click the target layers as stands, and we're going to indicate the source layer as roads in forest. And then we're going to click the target layer features, the spatial selection method, as within a distance of the source layer feature. So that should be the third one. So we're not going to do the 3D version. And so check the box next to the apply a search distance, which it already is, and we're going to indicate 50 feet. So I'm going to change this to 50 and make sure I change the unit to feet, and I'm going to click apply. So now you have the selection result includes all saw timber stands where harvesting is allowed, which are closer than 50 feet to the roads. And so you can see that there are 73 selected attributes. And so now we will select those stands satisfying our conditions, which are completely within certain distance to the roads or whose centers are within a certain distance to the road. So for these tasks, we need to first create a buffer around the roads. So buffering involves the ability to create distant buffers around selected features. Buffers are created as polygons because they represent an area around a feature. They're typically used with a point or linear features. The generation of buffers is frequently based on a distance from that feature or a specific attribute of that feature. So some features may have a greater zone of influence due to specific characteristics, such as a primary highway would generally have a greater influence than a gravel road. So accordingly, different size buffers can be generated for features within a data layer based on selected attribute values or feature types. So there's different ways. There's two different ways to create buffers at a specified distance. So all buffers for your graphics or features will be created at a distance you enter here or as multiple rings. This will create one or more buffers at multiple distances around your graphics or features. So this one, we're going to first select the Geoprocessing tab, which is up here, and select the Buffer tool, which is the very first one, and a dialog box will pop up. So in the dialog box, answer that you want the buffer features of the layer roads and forest as the input feature. For the output feature, click the browse button to make sure you are saving to the correct directory. And so we're saving in this geodatabase. And so now I'm going to enter the file name as roads in forest buffer, which it already has done here. And in the linear distance field, I'm going to indicate 1,000 feet. Make sure you change the unit from meters to feet and then click OK. And so now it's created all these awesome little yellow buffers that are 1,000 feet around each segment of road. So there's a lot of roads, so there's a lot of buffers. So now we want to dissolve these individual buffers into one so we can get an idea of the boundary of these buffers around these roads. So we're going to dissolve them by clicking on the clicking on the Geoprocessing tab, clicking the Dissolve tool. For the input features, you will select the buffer layer you just created, so this roads in forest buffer, and then for the output feature class, you're going to rename it as Buffer Dissolve. And then click OK. And so after a while, you get a layer that has dissolved buffers around the roads on your view. So now you can remove the original buffers layer by clicking right and removing it. So now we want to make the color of this new buffer layer transparent. So I'm going to go right click on it, go to properties, click symbology. So here I'm at general, click symbology. I'm going to click the current symbol, make the fill color no color, and make the outline color something that is distinct. So, and then make it maybe a 1 width. Click OK, apply, and so now we can see this dissolved buffer around the entirety of our stands and roads. Yeah, so this is our 1,000 feet giant buffer that is around all of our selected roads. So now we're going to select stands which are located within 1,000 feet to the roads, So we're going to repeat the same query to select saw timber stands on standard forest lands again. So I'm going to go to the selection menu. I'm going to click select by location. In the drop-down menu, I want the same select from the currently selected features in. I'm going to click the target layer as stands. The source layer is buffer dissolve. And the spatial selection method is target layer features are completely within the source layer feature. So target layer are completely within the source layer feature. And then click apply. And so that diminishes the number of selected attributes by about 60. So now we have 38 selected, which are completely the roads or the stands that are completely within 1,000 feet of roads, which means that they are harvested. So harvesting is allowed there. So now we are going to select stands whose centroids are located. So the center point are located within 1,000 feet of the roads. So I'm going to repeat the same query. So I'm just going to keep it up. From the drop-down menu, keep it at select from the currently selected features. Stands as my target layer. The source layer will be buffer dissolve, and my spatial selection will change, and it will be this very last one is have their centroid in the source layer feature. And I'm going to make it 1,000. So I'm going to apply a search distance to be 1,000 feet, and I'm going to apply. And so that actually doesn't really change much. It keeps it at 38 selected attributes, which is fine. So that is how you perform different queries, different operations to select areas within, around, that intersect different layers. And this helps you be able to do your assignment, which involves finding stands suitable for watching birds by hikers. So you can use techniques practiced in this exercise by selecting the RCW, so using the like operator, which that's hinted in the assignment. So there's many attributes that use the RCW headline, so we're going to use the like operator to select all of them that have this RCW mentioned in their field, and you're going to essentially designate stands that are more than 50 feet away from the roads and have intersections within the hiking trails. So I will not do this with you, but I will suggest selecting all the stands within 50 feet of the roads you can select these stands. So if you clear all your options and then selecting stands, it's been the attribute table, select by attributes, select by location, you can select the target layer, select features from, I would start with that, select features from the stands, and your source layer being your roads in your forest, and then are within, so having them are within a certain distance of 50 feet. So that's how I would start there. And then once those are selected, you can switch the selection by clicking the selected attributes. So down in this table options, clicking switch the selection, and that will make it the opposite. So everything that is not within 50 feet of the roads. And then from there, you can go into the intersected, select those intersected by the trails. So that's when you would go back to select by location with the everything that's currently selected in the stands, and then the source layer will be your trails, and then everything that is intersected the source layer feature. And then that is how you'll get the attributes that you then will want to designate for protection of the RCW from the selected set of stands that you have created by first finding them within 50 feet, switching their selection, finding those that intersect with trails, and then selecting the attributes by the land class using the wildcards that is using this like operator. So exactly the single quotation with the percent sign, RCW percent sign, single quotation, and it should operate successfully. So yeah, and then you will create a professional layout containing the current map. So you'll want to include 2 answers, or you'll want to include the necessary map elements and saving it appropriately, and then finally answering these 2 questions that is at the end of the lab, such as what is the total area. So you can, after selecting all of those, so you would right click the land class field, click summarize, and then you can click the GIS sum and click OK, and then it should come up with another table that tells you the sum of all the acres that have been selected that are associated with these selected stands, and then what are the stand ID numbers for the stands that meet the criteria. I believe there should only be 4, so if you get 4 of them, you've done it successfully. So yeah, and then you can save your map as a JPEG, TIFF, or PNG, and then upload it to Canvas assignment. You can put those 2 answers on the layout of the map if you like, or you can put them in a map document, save it, upload it to Canvas as well, or put it in the text entry on the Canvas assignment, whatever floats your boat. So yeah, you can definitely ask me questions. You can email me, text me if you like. My phone number is on my email if you want a fast reply, but I'm here to answer all of your questions about this assignment. So let me know if you have any, and I will talk to you next week for Lab 9. So you have until the end of the semester to finish this one, and hopefully you can figure out the problems you've been having with GIS very soon. So thank you for listening. Goodbye.